In H2S, sulfur is 94.11%, subtract it from 100, hydrogen is 5.89%. In water, oxygen is 88.89%, subtract it from 100, and hydrogen is 11.11%. In case of sulfur dioxide, percentage of both sulfur and oxygen is 50% each. We shall find out the weight of sulfur which combines with 1 atomic mass unit of hydrogen, weight of oxygen which combines with 1 atomic mass unit of hydrogen, and find a ratio between these two. Simple whole number ratio after rationalizing. And here we know ratio between weights of sulfur oxygen is 50-50 or it is 1:1. Here 5.89 parts by weight of hydrogen combined with sulfur equal to this, and 1 will combine with 5.89 parts by weight of hydrogen combined with 94.11 parts by weight of sulfur, एक part by weight of 94.11 over 5.89. It is approximately 16. It is approximately 16. We can make it a near whole number. There 11.11 parts by weight of hydrogen combined with 88.89 parts by weight of oxygen, parts of oxygen, 1 part by weight of hydrogen, 88.89 over 11.11, it is 8. So ratio between weights of sulfur oxygen which combined with the same weight of hydrogen is sulfur and oxygen which combine with same weight of hydrogen is 16:8 or it is 2:1. This ratio is 2:1, 1:1. We may make it 2:2. So 2:2 and 2:1 make a simple whole number ratio. It makes the simple whole number ratio when sulfur and oxygen separately combined with hydrogen. Ratio between weights of sulfur and oxygen which combined with same weight of hydrogen was 2:1. 2:1. When these combined directly, the ratio was 1:1 or 2:2. So these make a simple whole number ratio and illustrate the law of multiple proportions. And illustrate the law of multiple proportions. So this was the first numerical problem related to law of reciprocal proportions. We shall discuss another between nitrogen, hydrogen and chlorine. Between nitrogen, hydrogen and chlorine. Nitrogen, hydrogen and chlorine. Nitrogen and hydrogen form ammonia. This compound is nitrogen trichloride and explosive, and we know this is HCl. This is HCl. In ammonia, nitrogen is 82.35%, therefore hydrogen is 100 minus this 17.65%. In NCl3, nitrogen is 82. Chlorine is 88.32%. Therefore, nitrogen is 100 minus this, and it is 11.68%. It is 11.68%. In this case, we are to find the weight of hydrogen, which would combine with, say, 1 atomic mass unit of hydrogen, 82.35 parts by weight of 82.35 parts by weight of nitrogen combined with 17.65 parts by weight of hydrogen, एक part by weight of 17 point this over 82.35, it comes out to be 0.2, maybe 1. If here 11.68 parts by weight of nitrogen, 88.32 parts by weight of chlorine, take 1 part by weight of nitrogen, 88.32 over 11.68, it comes out to be about 7 point approximately 6. We have so ratio between weights of hydrogen chlorine comes out to be 0.21 is to 7.6. Rationalizing, divide both by the smaller one, 0.21. This ratio comes out to be 0.21 over the 0.21, it is 1 is to 35.5, and directly in HCl it is 1 is to 35.5. It is 1 is to 35.5. These two ratios are same. The H is to Cl. The two ratios are same, and hence illustrate the law of reciprocal proportions. So, in ammonia, we determined weight of hydrogen, which combined with one atomic mass unit of nitrogen, it came out to be 0.21. Number of parts by weight of chlorine, which combined with 1 AMU of nitrogen, it came out to be 7.6. Ratio 0.21 is to 7.6, it is 1 is to 35.5. Directly also, ratio between weights of H and Cl is 1 is to 35.5. These ratios are same, could have been a simple whole number ratio, but being same also serves our purpose. So it is the illustration of law of reciprocal proportions. We come to the next law in this sequence, and that is Gay-Lussac's law of gaseous volumes. It deals with the volumes of the reactants. There is no consideration of weight in it. So we have Gay-Lussac's law of gaseous volumes, because it is more convenient to consider gases in terms of volumes. We have hydrogen plus chlorine give rise to HCl. It is a balanced chemical equation. Hydrogen is gas, chlorine is gas, hydrogen chloride is gas. This equation suggests if we have 1 liter of hydrogen, it will require 1 liter of chlorine and give us 2 liters of hydrogen chloride. Ratio between volumes of hydrogen, chlorine and HCl is 1 is to 1 is to 2. It is a simple small whole number ratio. It is a simple whole number ratio. We have nitrogen balanced chemical equation. It is a gas, it is a gas, it is a gas. We have 1 liter of nitrogen, 3 liters of hydrogen, and we get 2 liters of ammonia. The ratio between volumes of nitrogen, hydrogen, ammonia is 1, 3 is to 2. It is a simple whole number ratio, but it is more practical to ignore this unit of volume, that is a liter. We have considered the volumes in accordance with the balanced chemical equation 1 liter, 3 liter, 2 liters. We may generalize it N2 plus 3H2 give rise to 2Na3. Instead of 1 liter, suppose we have 10 liters of nitrogen. How many hydrogen is required? 10 into 3, 30 liters. And how much ammonia we get? We get 20 liters. We have 200 liters of nitrogen. We shall have to take, multiply 600 liters of hydrogen, and how much of ammonia we get? This is 400 liters. So, generalizing, we shall not select liter as a unit. It may be a liter, it may be a kiloliter, and so on. So we write 1 volume, 3 volumes, and 2 volumes. If we had directly started with 1 volume, 3 volume, 2 volumes, it would have taken some time for you to grasp it. But making it 1 liter, 3 liters, 2 liters, 10, 30 and 20, 200, 600, 400, and then coming to the conclusion that liter may be rejected as unit of volume. If we have 1 volume of nitrogen, it will require 3 volumes of hydrogen and evolve 2 volumes of ammonia. In more general terms, if we take 1 cylinder of nitrogen, we may not know the exact capacity of that cylinder. We have, say, taken 1 cylinder full of nitrogen. This is the cylinder full of nitrogen. We do not know its volume, what volume it really occupies. We shall have to take such 3 cylinders of hydrogen, and we shall get 2 such cylinders of ammonia as a product. This means volume. We have selected or randomly taken this cylinder filled with nitrogen at a given temperature pressure, say STP. This will be taken as a unit, a mark of unit. This is the volume of nitrogen. 3 such cylinders of hydrogen are required. 2 such cylinders of ammonia will be produced. This means we are selecting it in terms of volumes. So, whenever gases combine, they do so means combine in simple whole number ratio of volumes. Combine reactants. Reactants are in a simple whole number of volume. Also the products, if it is a gas. Nitrogen is gas, hydrogen is gas, ammonia is gas. This law will extend from reactants to the products. Volumes, ratio between volumes of nitrogen, hydrogen and ammonia, reactants and product is a simple whole number ratio, and this is 1:3:2. Hydrogen is a gas, chlorine is a gas, product is also a gas. The law extends to products also. Ratio between volumes of hydrogen, chlorine and hydrogen chloride is 1:1:2. It is a simple whole number ratio. It may always not be so. For example, we have another reaction. Let me have some space. NH3, it is a gas, plus HCl, it is a gas, combine to form ammonium chloride, but this is not a gas, it is a white solid which appears as a sublimate. Ammonia and HCl gases are allowed to come into contact. We get ammonium chloride, these gases vanish, and we get ammonium chloride, which is a solid substance. We may observe it. This is a glass tube. This is a glass tube. We introduce ammonia from this end and HCl from this end. This is a gas, ammonia is a gas, and at this spot we find white opaqueness. A white powder-like substance has appeared. This is ammonium chloride. This is ammonium chloride sublimate. So this is slightly away from this. Ammonia is entering, HCl is entering from this side, and this combination is not in the center towards ammonium chloride. We shall discuss it in gaseous state of matter, that is the other chapter. It is a lighter gas, will move faster. It is a heavier gas, will move just slower. And this combination takes place not in the middle, slightly towards hydrogen chloride, and we get a solid substance. So here this law is applicable to reactants only. Product is not a gas. We have NH3 is to HCl, it is 1 is to 1. Ammonium chloride, which is the solid, is excluded from it. Is excluded being a solid. So this is the application of Gay-Lussac's law. We are still to define this law properly. So everything before us, gaseous reactants, gaseous product, gaseous reactants, gaseous product, the law extends to reactants and products both. Gaseous reactants, लेकिन solid product, law holds for reactants only and not the product. This is about substances in gaseous state because it is simpler to measure or express gases in terms of volumes rather than in terms of weight. We shall define this law now. Gay-Lussac's law of its definition. When gases or gaseous substances react, these do so in terms of volumes. These do so in which bear a simple whole number ratio with the products also, but condition if gaseous. If the products are gaseous, it will extend to the products also. This is the simple definition of Gay-Lussac's law. This is simple Gay-Lussac's law. Gases, combined gases react do so in terms of volumes which bear a simple whole number ratio with the products also. Condition is if gaseous. Let us apply it to a numerical problem. What volume of oxygen is required to burn